Welcome back. Last time we delved into LLaMA, a model that really set a new standard in natural language processing by focusing on efficiency and accessibility. With its open source foundation, it showed us that high-performing models could be built without the need for proprietary data, which was a huge leap in making language models more accessible. Remember how we talked about how LLaMA scaled language models without cutting corners on performance?
Absolutely. LLaMA really broke down some barriers. And now, I'm guessing we're about to see what happens when you build on that open source language model foundation by adding visuals.
Today, we're exploring LLaVA, a fascinating next step that extends those LLaMA innovations into the multimodal space. So instead of focusing only on language, LLaVA is trained to understand both visual and textual inputs. This shift is a big deal, because it brings us closer to building AI that can interpret and respond to the world in a way that resembles how we do with both eyes and language.
That sounds powerful. So, this episode is important because we're looking at the very first multimodal model that uses GPT-4 generated data for training in both text and visuals. This kind of instruction tuning for visual tasks is completely new, right?
Exactly, and it's a significant contribution. They're pioneering visual instruction tuning here, letting LLaVA handle complex tasks that combine both images and text, which requires it to reason across both types of data. Not only does it combine a CLIP-based vision encoder with a language model, but it also introduces new benchmarks, like LLaVA Bench, to truly assess its performance on challenging multimodal tasks.
So, we're going to cover how LLaVA was built and why it's achieving state-of-the-art results, especially on something like Science QA. Plus, the fact that the researchers made everything open source, from the model to the data, is huge for furthering research in this field.
Yes. LLaVA's open-source approach is set to inspire a lot of innovation in visual language models. We'll break down the key aspects of its architecture, the novel benchmarks, and how it's performing at a level that rivals specialized models in both text and vision tasks.
Sounds like we're in for a great discussion. Ready to dive into LLaVA's journey into visual instruction and multimodal AI?
Let's jump right in and explore how LLaVA bridges language and vision with cutting-edge techniques. All right, we're diving into the abstract of this research. This part is all about introducing the innovative concept of LLaVA, which stands for Large Language and Vision Assistant. It's a large multimodal model that aims to connect both visual and language processing abilities in a single system. The main idea is to allow this system to understand instructions involving both images and text, a bit like teaching a model to handle what both the eye and the ear would pick up together.
So, it's trying to get a model to understand instructions that combine visual and textual elements? That sounds like it could be pretty complex.
Exactly. And to make this happen, the researchers used a technique called instruction tuning. In simpler terms, they trained this model by feeding it instruction-based data that covers both image and text. Usually, instruction tuning helps language models perform well on new tasks, even when they haven't been explicitly trained on them before. This paper takes that idea and applies it in the multimodal field, so involving both vision and language.
Got it. They're extending a language-focused technique to something that can handle images too. I wonder how they created this mixed instruction data?
Great question. They actually generated multimodal instruction following data using language-only GPT-4. This was a creative solution because they didn't have pre-existing data that combined vision and language instructions in the way they needed us. By generating their own, they could create instructions where the model needed to understand both words and pictures together.
That makes sense. So, GPT-4, which usually works with text, helped create these visual text instructions. Did the researchers test how well LLaVA performs with this setup?
Yes, they did. They created 2 new benchmarks specifically to test LLaVA's capabilities in visual instruction following. These benchmarks contain tasks that are designed to challenge the model with complex, real-world, image-based tasks.
And how did it perform in those tests? Did it show improvement over models that weren't tuned with this multimodal data?
It did, indeed. LLaVA demonstrated some impressive multimodal chat abilities, which means it could handle questions about images in a conversational style. In fact, in some cases, it acted quite similarly to multimodal GPT-4, especially when dealing with images it hadn't seen before.
So, this instruction tuning actually made it perform pretty close to GPT-4, but in a way that's specialized for images as well. That's quite an achievement.
Absolutely, and beyond general tasks, they also tried fine-tuning it on Science QA, which is a specialized dataset for science questions that can involve images. With this tuning, LLaVA and GPT-4 together achieved a top accuracy of 92.53%, which is state-of-the-art for that benchmark.
That's impressive, especially since science questions can get tricky. It sounds like they also made their data and code open source. Did they have a specific reason for that?
Yes, that's a good point. They're making everything available to encourage further research in visual instruction following. They hope other researchers can build on LLaVA or create new models that also combine language and visual capabilities effectively.
That openness could definitely accelerate progress in this area. It seems like LLaVA might inspire more models to combine visual and language processing.
Exactly. It's all about pushing boundaries and opening up new possibilities for general-purpose assistants that can understand complex, multimodal instructions. So with LLaVA, we're one step closer to models that really see and understand in a more holistic way. All right, let's transition from the abstract into the introduction. Here, the focus is on how humans naturally interact with the world through multiple channels like vision and language, each with its unique advantages. The researchers highlight how these modes allow us to interpret and communicate complex ideas effectively. In AI, there's a big ambition to replicate this kind of multimodal understanding.
So, they're aiming to make an AI that understands both what it sees and hears, like we do. That sounds like it would help in creating more adaptable and user-aligned systems.
Exactly. The goal is a general-purpose assistant that can understand and respond to multimodal instructions, so it would be able to help with all kinds of real-world tasks. But achieving this requires going beyond the typical single-channel models we usually see, where vision models handle only visual tasks and language models handle text.
I see. Usually, we have separate models for images and text, but they're not designed to work together as an integrated system. Is there a movement toward combining them now?
Yes, and this paper notes that there's been a recent surge in developing vision models that incorporate language-based elements. This includes advancements in tasks like image classification, object detection, segmentation, captioning, and even generation. However, while these models can use language to describe visuals, their interface is often limited. They're typically fixed in function and can't interact dynamically based on the user's instructions.
Right. It sounds like they lack flexibility. They can identify objects or describe scenes but aren't truly interactive in the way humans are when combining both vision and language.
On the other hand, large language models, LLMs, like ChatGPT and GPT-4, are proving how powerful language is as a universal interface. They allow a model to switch between tasks just by changing the instructions, which creates a more dynamic interaction. This flexibility is what researchers are trying to bring to multimodal AI.
That makes sense. So, they're aiming to replicate that flexibility in a way that also encompasses visual data, making an assistant that can adapt across tasks seamlessly.
Exactly, and to make this happen in the visual domain, they introduce a concept called visual instruction tuning. This is essentially instruction tuning but extended to handle both images and language, a novel approach they believe could pave the way for a true visual assistant capable of handling diverse multimodal tasks.
So, instruction tuning is the technique they're adapting for this. That's interesting, especially since it's already shown success in improving how language models generalize to new tasks.
Yes, and adapting it for multimodal data is key to their approach. They're not just taking existing image-text pairs, they're actively converting them into a format that the AI can follow as instructions. This structured tuning process is intended to train the model to handle complex visual and linguistic inputs together.
It sounds like this structured approach really helps the model understand complex multimodal instructions. It's fascinating to see how they're applying language model techniques to bridge the gap in vision-based AI.
Absolutely. By combining the strengths of both vision and language instruction tuning, they aim to achieve a new level of interactivity and adaptability in AI. ATI. It's an exciting development for creating a more holistic assistant capable of true multimodal understanding. All right, moving from the introduction, we now enter the related work section. This part explores past efforts in creating multimodal instruction-following agents and sets the context for how LLaVA is distinct.
So, is this section mainly a comparison with other multimodal systems?
Exactly. The researchers compare LLaVA with two main categories of multimodal models. The first category includes end-to-end trained models tailored for specific tasks. Think of applications like vision language navigation and image editing, where models are designed to respond to natural language in task-specific environments.
I see. So, these models are very specialized, like ones specifically for navigation or image editing. But are they flexible in taking on new tasks?
Good observation. That's one of their limitations. These models are typically good at their intended tasks, but they aren't designed for the flexibility needed in a general-purpose assistant. The second category includes systems that combine multiple models, often orchestrated by a large language model, LLM, as the coordinator.
So, in this setup, each model might handle a specific function, and the LLM directs them? It sounds like a clever workaround to bring different abilities together.
Exactly right. Some well-known examples include Visual Chat GPT and MMREACT. They coordinate models for diverse capabilities but still depend on an LLM to act as the manager. However, LLaVA's aim is different, Smith. Rather than coordinating different models, it's an end-to-end system designed to handle a variety of tasks directly.
So, LLaVA tries to bring all these abilities together into a single model, right? That would make it more versatile than both specialized and coordinated systems.
Exactly. And then there's also a section here on instruction tuning. Instruction tuning in NLP has been very successful with models like Instruct-GPT and FLANT5. Researchers apply this approach to make LLaVA a more interactive, instruction-following multimodal model by training it with complex vision language instructions.
That's interesting. So, they're adapting what's been working for language models to this multimodal space. Did they face any unique challenges in tuning a model to handle both images and text?
Yes, the biggest challenge is in obtaining multimodal data that aligns well with instruction tuning. Unlike text data, multimodal instruction following data is scarce. The team created their own pipeline to convert existing image-text pairs into instruction-following examples using GPT-4, ensuring the data is rich enough for training this multimodal interaction.
Makes sense. By crafting their own data, they could make sure it actually aligns with what they want the model to learn. So, they're filling a gap by adding this new data structure into the field?
Exactly. They are pioneering this visual instruction tuning in multimodal A1TI, which hasn't been fully explored before. This innovative data approach is what allows LLaVA to engage in complex multimodal interactions seamlessly. All right, building on from the related work, we now dive into how the researchers generated the data needed for LLaVA's visual instruction abilities. This section focuses on the innovative use of GPT-4 to create multimodal instruction-following data. The challenge here is that existing image-text data, like captions from datasets, aren't enough for true instruction following. So they devised a method to turn standard image-text pairs into rich instruction-style data.
That sounds like they're transforming simple data into something more complex. How did they actually use GPT-4 to create this new data?
Good question. They start by using images paired with captions, and then prompt GPT-4 to generate questions about the image, designed to guide a model to follow instructions specific to the visual content. Think of it as teaching GPT-4 to ask and answer questions about what's happening in an image, which is then used to train LLaVA.
I see. So, GPT-4 is basically generating questions that make the model think about the image in a step-by-step way. Does this include simple questions? Or do they try for more complex ones as well?
They indeed included different types. The generated data falls into three main types: conversational responses, detailed descriptions, and complex reasoning questions and tests. Conversational responses are more straightforward, like, "What do you see in the image?" But the complex reasoning questions are crafted to make the model think deeply, requiring logical steps to answer correctly.
That's interesting. It sounds like they're simulating a full dialogue about the image, pushing the model to interpret beyond just object recognition.
Exactly. By building on these layers of questioning, LLaVA can learn to handle both simple descriptions and deeper, more contextually aware questions. They generated a large data set, over 150,000 unique samples, that include a mix of these question types to cover a wide range of interaction scenarios.
That's impressive. So, they're using GPT-4's responses to build this extensive dataset for training LLaVA. Did they mention any specific advantages of using GPT-4 over other models for this task?
Yes, they did. Through their experiments, they found that GPT-4 consistently provided higher quality responses, especially when the questions required reasoning or spatial awareness. This choice helped ensure that the instruction data was as rich and nuanced as possible, making it ideal for training a model like LLaVA to interpret visual data with a conversation-like quality. All right, let's move smoothly into how they've fine-tuned LLaVA for visual instruction following. This section covers their two-stage tuning process, which helps the model integrate vision and language instructions more effectively. The first stage is all about aligning visual features with language by pre-training on a large set of image-text pairs. They're making sure the model learns to map visual content into a format that the language model can understand.
So, this alignment process is sort of a bridge, allowing the visual encoder's output to be compatible with the language model's input.
Exactly, that's the idea. They used image-text pairs from a dataset called CC3M, converting each one into an instruction-following format. Here, they froze the weights of the visual encoder and the language model to keep things stable, only allowing adjustments in a special projection layer. This method efficiently aligns visual features with the language embedding space without altering the core model weights.
Interesting. So, it's like they're optimizing that projection layer to make the visual data speak the same language as the text input.
Precisely. Once this alignment is set, they proceed to the second stage, which is an end-to-end fine-tuning phase. In this phase, they take the now-aligned model and train it on a dataset specifically created for visual instruction following. This dataset includes the conversational, descriptive, and complex reasoning examples we discussed before, and it's sampled to give the model a balanced training experience.
Got it. And I assume the end-to-end tuning phase now allows updates across the entire model, not just in that projection layer.
Yes, you've got it. This phase allows both the language model and projection layer to learn together, refining the model's ability to respond to complex, multimodal instructions. This two-stage approach is critical for the model's performance because it ensures that visual understanding is robustly embedded in the language processing pipeline.
It sounds like this method really helps create a smoother interaction between visual and language inputs. I can see how these two stages prepare LLaVA for nuanced, real-world tasks.
Absolutely, that's the goal. By building this structured approach to visual instruction tuning, they've managed to create a more responsive and versatile assistant, ready to tackle diverse multimodal challenges with depth and clarity. Now that we've covered the fine-tuning techniques, let's look at how LLaVA's tuning enables it to function as a multimodal chatbot. This section is really about how well the model handles real-time conversations that involve both text and visual inputs.
So, this multimodal chatbot can respond based on visual context too, right? How does it handle conversations differently than standard chatbots?
Exactly. The difference here is that LLaVA can take an image as part of the conversation, interpret it, and then respond in a way that's conversational and relevant to the visual details. To test this, they fine-tuned it on a large set of language image instruction following data, about 158,000 examples. The aim was to ensure it could smoothly handle multiple conversational turns and respond in a way that feels natural.
That's quite a lot of data. Does it handle different types of responses? Or is it mostly one type of interaction?
Good question. It actually handles three main response types: conversational responses, detailed descriptions, and complex reasoning. This setup helps it tackle everything from casual image-based chat to more complex interactions where it has to think critically about what's in the image.
So it's not just describing what's in the image. It can also respond to more abstract questions about it?
Yes, exactly. For instance, if you asked about something unusual or complex in an image, LLaVA can give a response that goes beyond simple labels or object recognition. It's capable of reasoning about relationships within the scene and following through on questions that require in-depth answers. This level of interaction is what makes it feel more like a conversation rather than a one-time description.
I see. And it's not just limited to what it's trained on, right? It can generalize to new images too?
That's right. The interesting part is that LLaVA can generalize fairly well to unfamiliar images, thanks to the diversity in the training data and the multimodal instruction tuning approach. It demonstrates impressive results, even when handling images that it hasn't seen during training. This capability is crucial for real-world applications, where the model might encounter new visual inputs frequently.
That's really impressive. So, with this training, LLaVA is well prepared to act as a dynamic visual assistant in real-time conversations.
Exactly, and by training it to handle a range of conversational depths and complexities, they've made it adaptable and capable of offering more human-like interactions around images. This multimodal chatbot application is a big step toward making visual AI assistants more intuitive and versatile. All right, transitioning from LLaVA's multimodal chatbot capabilities, let's dive into its application on the Science QA benchmark. This is a specialized dataset designed to test models on a wide range of science-related questions, covering multiple subjects and requiring a mix of reasoning, language understanding, and even visual interpretation.
So, Science QA isn't just about answering simple questions. It also challenges the model to understand more complex scientific topics and images, right?
Exactly. Science QA includes over 21,000 questions across diverse topics in natural science, social science, and language science. The unique part is that some questions have accompanying images that provide additional context, making this a true test of multimodal reasoning for LLaVA.
Got it. So, LLaVA has to interpret the images as well as the questions to provide accurate answers, which sounds pretty challenging.
Yes, it is. For this benchmark, LLaVA was trained to not only select the correct answer from multiple choices, but also to give reasoning in natural language that explains the answers. This extra step helps in building a model that can justify its answers, which adds an educational layer to its responses.
That's an interesting approach. So, it's not just answering, but also explaining the science behind its choice. How does LLaVA's performance compare to other models on Science QA?
Great question. LLaVA achieved close to state-of-the-art accuracy, reaching around 90.92%, which is quite impressive. When they combined it with GPT-4 as a judge to review answers where LLaVA's response differed, accuracy went up even further, achieving a new benchmark at 92.53%. This hybrid approach leverages GPT-4's reasoning capabilities to confirm or adjust responses.
So, GPT-4 is helping double-check certain answers, especially where LLaVA's response might have been uncertain. That's clever. It sounds like they're combining strengths here to push accuracy as high as possible.
Exactly. By combining LLaVA's visual and multimodal strengths with GPT-4's robust reasoning, they've created an ensemble approach that leads to very accurate results. This sets a high standard for multimodal science reasoning in AI, where understanding and accuracy are both enhanced. Now, wrapping up with the conclusion, the researchers emphasize that their work on LLaVA is a pioneering step in visual instruction tuning. Through the development of a new data pipeline and the innovative use of GPT-4 to generate multimodal instruction data, they've introduced a model capable of following visual instructions in a way that aligns closely with human intent.
So, they're viewing LLaVA as a foundation for future advancements in visual instruction following models. It seems like they've set a high bar with these capabilities.
Exactly. LLaVA not only sets new standards with its state-of-the-art accuracy on the Science QA benchmark, but also brings strong visual chat capabilities to the table. They've shown that it's possible to build a single multimodal model that can interpret and respond to complex visual tasks, thanks to their structured approach to instruction tuning.
That's impressive, especially considering how challenging multimodal interactions are. Do they see this as an evolving field with more benchmarks and models to come?
Yes, they hope that by releasing LLaVA and making their data and models open source, it will inspire further research and innovation in building even more sophisticated multimodal models. Their benchmark, LLaVA Bench, is also intended as a starting point for studying and improving the multimodal instruction following capabilities of AI. They're optimistic that this will contribute to building general-purpose assistants that can handle real-life visual tasks more intuitively. Well, that wraps up our deep dive into LLaVA. We've seen how it builds on LLaVA's language-focused breakthroughs by extending into the multimodal space with visual instruction tuning and a seamless integration of vision and language.
Right. And I think it's incredible how they tackle the challenges of training on both image and text inputs, especially with those new benchmarks and GPT-4 generated data. It really sets a new standard for what multimodal models can do.
Absolutely. The way LLaVA handles complex reasoning across both text and images, like in Science QA, shows us the potential of this approach for future AI applications. And being open source, it's paving the way for the research community to take it even further.
Definitely. I can't wait to see how other researchers build on LLaVA's foundation. Thanks for guiding us through all the details, and thanks to everyone listening for joining us.
Yes, thank you for tuning in. We hope you enjoyed this exploration into the next frontier of multimodal AI. Stay tuned for more insights, and as always, thanks for listening.